So this video is a reminder about receptors in the autonomic nervous system. And I've already drawn out this picture, and I'm just going to add the neurotransmitters to it and talk about their receptors. So we have cholinergic receptors and adrenergic receptors. So cholinergic receptors receive acetylcholine. Adrenergic receptors receive norepinephrine. So let's put acetylcholine and epinephrine, norepinephrine. So we have nicotinic cholinergic receptors and muscarinic. Cholinergic receptors. We have beta adrenergic and alpha. Beta and alpha. Okay, so in the somatic system, so this is somatic motor. So we have the neuron that comes out of this spinal cord that goes to a skeletal muscle. At the neuromuscular junction, well, I guess I'll leave it black. So acetylcholine is secreted there. This synapse at the neuromuscular junction, at the skeletal muscle, is always stimulatory. Always stimulatory. So these receptors that are taking the acetylcholine are going to be nicotinic, because nicotinic receptors are always excitatory. Okay? At the ganglia, or the presynaptic or preganglionic meets the postganglionic neuron, we have acetylcholine, and the receptors here are going to be nicotinic, because this is always going to be stimulatory. Also sympathetically, between the preganglionic neuron and the adrenal gland, the adrenal medulla, this is going to be acetylcholine, and it is going to contain, these are going to contain nicotinic receptors. This is going to be stimulatory. Same thing here. The parasympathetic pre to the parasympathetic postganglionic, there is going to be acetylcholine. The receptors are going to be nicotinic, and it's going to be stimulatory. At the effectors in the parasympathetic, it's still going to be acetylcholine, but the receptors are going to be muscarinic, because this can be stimulatory or inhibitory. So this can be, muscarinic receptors can be stimulatory or inhibitory. Sympathetically, The neurotransmitter is different. It is norepinephrine or epinephrine. The receptors are either going to be beta or alpha adrenergic, and it's either going to be stimulatory or inhibitory. So that is how receptors work, and please review this. You need to kind of understand this and remember this, especially about the muscarinic receptors and the beta and alpha receptors. Keep in mind, since they're either or, it depends on the receptor and the neurotransmitter. So, for example, keep in mind acetylcholine binding to cardiac muscle, it's going to bind to muscarinic receptors, and its effect on the heart is going to be inhibitory. It's going to slow heart rate. At the neuromuscular junction, acetylcholine is going to have nicotinic receptors, and it's going to be stimulatory. Because remember, nicotinic is always stimulatory. Acetylcholine, parasympathetically to the smooth muscle of the digestive tract, is going to be stimulatory. So again, those are muscarinic receptors because they can be either or. Okay, norepinephrine uses beta or alpha adrenergic receptors, and they too can be positive or stimulatory or negative or inhibitory. So beta receptors at the cardiac muscle going to be stimulatory. It's going to increase heart rate. Beta receptors or alpha receptors in the digestive tract going to be inhibitory. It's going to slow down or stop digestion. Okay, so review this. Hopefully this is an easier way to understand these receptors, but make sure that you know this.